Out of the box, modern AI coding assistants operate in an unstructured void. They guess at your architecture, your style, and your workflows, until a framework forces them into a strict, highly organized environment. That framework lives inside the .claude folder. It appears in the root of your project directory, operating as the local control center for your AI assistant. Most developers treat this auto-generated directory as a black box. They see it appear, they commit it, and ignore it entirely, leaving the system running on default assumptions. We are going to open that box. We will architect the .claude protocol from the ground up, layering modular context, custom commands, and strict security boundaries. Mastering this protocol is how you scale a generic text generator into a highly integrated, context-aware engineering partner. We begin in an empty project repository. The foundational layer of this entire architecture is a single file, CLAUDE.md. The moment a session starts, the assistant reads this file directly into its system prompt. Whatever rules you define here become the absolute baseline for the entire conversation. This is where you declare your core engineering standards. You specify your build commands, like npm run test, whether TypeScript strict mode is actively enforced, and the overarching architectural patterns of the repository. What you do not include is verbose coding theory or full API documentation. This is an instruction manual, not a wiki. Plot instruction adherence against line count. Keep the file under 200 lines. Past that threshold, adherence plummets. When the file gets too large, context degradation sets in. The AI hallucinates variables and bypasses rules because core instructions are pushed out of memory. A monolithic system prompt simply fails as a codebase grows. To scale instructions effectively, we need a modular alternative. That alternative is the rules directory. This folder solves the token bloat problem inherent to a massive CLAUDE.md file. Instead of one giant text block, you split instructions by concern. You create distinct markdown files, one for API standards, another for testing rules, keeping the separation of concerns clean. The highest leverage mechanism in this tier is path-scoped rule injection, configured using a YAML front matter block at the top of these files. The paths field is a smart gateway. Opening a source API file pulls the corresponding API conventions document from the rules folder directly into the active context window. Conversely, editing a front-end React component blocks back-end rules from loading, keeping the prompt lean. Dynamic context injection ensures the AI reads only the instructions relevant to the immediate task, preserving instruction adherence without sacrificing the depth of your project guidelines. Context dictates how the assistant thinks. To control how it acts, we move to the commands directory. By dropping a simple markdown file into this folder, you create a custom project-specific / command. These commands execute shell scripts using a specific backtick syntax. You can run tests or inject live terminal outputs, like a git diff, straight into the prompt before the AI even evaluates your query. The limitation here is initiation. Commands are strictly manual macros. They wait for the engineer to type the exact trigger. To evolve from passive macros to active execution, you use the skills directory. Skills rely on YAML front matter to monitor the conversation. Instead of a / command, an autonomous sensor matches natural language requests against the skills description, triggering the workflow when needed. Unlike single-file commands, skills bundle auxiliary reference documents to execute complex sequences. True scaling requires moving past manual shortcuts. You engineer state-aware workflows that fire precisely when the context demands them. As workflows scale, heavy computational tasks will flood your primary session window with thousands of intermediate tokens. We offload that heavy lifting using the agents directory, where you define specialized subagent personas. Agents spawn isolated secondary sessions using standalone system prompts. You can assign faster, lower-cost models to these subagents for token-heavy code exploration without bloating the main session. You must restrict their tool access. A security auditor persona reads and greps, but requires 0 write permissions. To control permissions across the entire protocol, we use settings.json. This is the definitive governance layer over the assistant's capabilities. Here, you define explicit lists to allow routine bash scripts to execute freely, while permanently denying access to sensitive environments, like your .env files or your secrets folder. Offloading complexity to restricted subagents while enforcing strict global tool limits transforms a volatile language model into a predictable, secure enterprise asset. This entire system operates on a dual hierarchy. You have project-level configurations that you commit to Git for your team, and a global .claude folder in your home directory for machine local state. That global folder maintains your persistent cross-session auto-memory and handles any personal overrides, ensuring your local preferences never leak into the shared repository. The integration sequence is precise. Establish your core CLAUDE.md and settings first. Build manual commands. Modularize your instructions into path-scoped rules, and finally abstract heavy workflows into isolated agents. Standardize this directory as mission-critical project infrastructure. It demands the same engineering rigor as your Docker configurations or CI/CD pipelines. When engineered deliberately, the AI protocol conforms completely to your architectural vision, drastically reducing friction and maximizing your engineering leverage.